Okay, we're going to take a look at this example 11. Last example was fairly complicated, it had a lot of things you could see in a stoichiometry problem, but you don't often see all of those things. And so this one is a lot more straightforward, and I think a little bit more like what you would probably see on most problems where it's not quite as complicated. Now, the density is an excellent conversion factor. We want to make sure we take that away from the previous example, but that doesn't mean that density is always going to be showing up. Look at this example. It says the final step in the production of nitric acid involves the reaction of nitrogen dioxide with water. Nitrogen monoxide is also produced. How many grams of nitric acid are produced for every 100 grams of nitrogen dioxide? So first thing, pretty much is always the same, is if you don't have it, you're going to need to create an equation. So we've got to have an equation. If we don't have one of those, then we are not going to be very successful. So got to come up with a chemical equation. So let's go ahead and dive into that real quick. And so we're making the nitric acid, and we're making it from nitrogen. It says from a reaction of nitrogen dioxide with water. So these two are together, and then we're making this one. And then it says that we also make a bit of nitrogen monoxide. So it kind of takes a little bit of reading to sort all this out. So start here with the nitrogen dioxide. So it's got a prefix, di. So it's just going to be N for nitrogen, O2. All right. Now it says it's reacting with some water. And we're going to make the nitric acid. Always a good one to memorize, the nitric acid, because it comes up quite a bit. And then some nitrogen monoxide. So that means N, and then monoxide means 1O. Okay. So take a second, go ahead and balance that, see how you do, and then we'll pick up here in a second. Okay, so let's take a look at the balancing here. So nitrogens are looking pretty good. You got one over here and then one over there, so that's fine. So, oh, wait a minute, sorry. Two over here, one over here, so it's not fine. So we know we're going to need at least a two over here. So now the nitrogens are going to be okay. Let's take a look at the hydrogens. We've got one hydrogen there, and there are no others. And over here we have two, so that's going to be a bit of an issue. So now we're going to be kind of going down that fixes the hydrogens, but that's going to, of course, mess up the nitrogens. So we're most likely going to have to switch that over. And so if you look, we've now got one nitrogen and then so 1 times 2 here, and then 1. So this is 2 times 1, and 1, so that's 3. And then over here we have 1, so I'm going to go ahead and put in a 3. So now you got 3 nitrogens, and then on this side we also have 3. Hydrogens look like they're okay. So we got the 2 here, and then the 2 here. And then now we just got the oxygen. So 2 times 3 is 6, plus 1 is 7, and 2 times 3 is 6, plus 1 is 7. Something I tell students a lot is that oxygen will often sort itself out. So if you do oxygen last, it will often sort itself out. If you do it first, it can be really problematic. So okay, what do we have? We have 100 grams of nitrogen dioxide. And so let's go ahead and put right on top of the nitrogen dioxide 100.0 grams. So I always put the chemical that are given on top of whatever chemical that is. And so then it says that we're supposed to see, and that's starting to get a little muddied. So let's erase a bit of this. There you go, clean that up a little bit. And so what are they wanting? How many grams of nitric acid? So that's what they're looking for it in grams. So we're looking for, oops, that's not what we wanted. There we go. How many grams of nitric acid? Now, these are not discussed, so they're both getting an X. Basically means, hey, don't use those. They're not going to help you out in the problem. So when you do this, now we're going to be going from chemical A here to chemical B here, and we don't care about those two chemicals. So that's kind of what's going to go on. So from chemical A, we're going to start with the number, the unit, and the chemicals. So we're going to go 100.0, not a very good looking 0, grams of NO2. And then we're going to go ahead and convert it to moles. We always convert to moles if we don't have them. Now, if we did have moles, we could skip this step, but sadly we don't. So we're going to have to convert. So now we're going to go ahead and add up on our calculator. So hopefully you got your calculator out, or you've already done this, which is preferable. So we're going to add up 14.01 for my nitrogen. And then we're going to add that to 16 times 2, 16.00 times 2 for the oxygen. And we're going to get 46.01. 46.01. And now we're going to go into the mole ratio, which is going to be the chemical we want over the chemical we have. So it's always going to be, what do you want over what do you already have? So the chemical I want is B, my question mark. So I'm going to put 2, because that's the coefficient, 2 moles of the HNO3 on top of, the 3 moles of NO2. And then that is going to conveniently do some canceling for us. So if we're looking at canceling, we're going to have grams are gone, top and bottom. NO2 is gone, top and bottom. Moles are gone. So now we got moles of HNO3, moles of nitric acid. So if they said, if this word right here, grams, was replaced with how many moles, then we would stop right now. But they want grams, so we have to do that third step, that extra step. So just one more conversion factor right here. We want grams, so they go on top. We don't want these moles anymore, so they go on bottom. And then we just go ahead and we get out our periodic table and we add up how much the HNO3 weighs. Okay, so the hydrogen's 1.01. Okay, so let's add that to the nitrogen, 14.01, hit enter, and then add that to the 3 oxygens, which is going to be 48. But if you don't believe me, that's 48. Type in 16.00 times 3, close parentheses, and there we go. That is not what we wanted. Try this. 63. Oh, highlighter again. 63.02. Okay. So now we can make sure everything cancels. And it's really important in Stoic to make sure everything cancels. So see, moles are on top and bottom. So we have this, which is what we want. See, it's where our question mark is at. So that's good, right? So there's our question mark over there. And then grams, well, we wanted grams. So we got our chemical, we got our grams. Well, that's everything we wanted. Should be good. So let's run it through our calculator. So we go 100.0. And since this is on the bottom, we're going to divide. So divided by 46.01. Hit enter. Multiply by 2. It's on top, so times 2. Divide by 3. It's on the bottom. Hit enter. So I'm hitting enter after every step. So I'm not trying to dump it all in my calculator at once. That's never good. And then I'm going to multiply by 63.02. That is a 2. and then hit enter. And I'm going to get a 91.31348258. So if you come over here, that's 4 significant figures. Nothing else matters in significant figures because these are all conversion factors. So sig figs, conversion factors don't count. So our answer will have 4. So we're going to go with 91.31. There's 4 sig figs grams of nitric acid. And that would be our final answer. Okay, so a couple of things to take away from this is the steps are that you have to start with that balanced equation. So if you don't have the equation, then you're in trouble. Then putting the values on top so that we know where we're going and where we're going to. So I know that I'm starting here and I'm going to be going here. So where did I start? Where am I going? That's really important. So you got your balanced equation, you got what you have, what you want, and then you go ahead and you go through. You always start with the number they give you, and then you move forward from there. Knowing that it's what I want over what I have is also a very useful idea. So I'm going to pause it here before we move on to the next piece.